My name is Martin Lechner. I'm the CTO of Wikitude and the chair of ARML 2.0 Standards Working Group. And what I'm essentially, what I want to do today in the webinar is giving you an introduction into augmented reality itself, in case if you're not really familiar with AR, augmented reality, or you just want to hear a bit more about it. You will get a kind of a quick rundown of augmented reality and what it can do. And then also I will talk briefly for 1 or 2 slides about Wikitude as a company. But the main part of the presentation will obviously be ARML 2.0, what it is, why we created it, what it can do, and how you can essentially make use of it. So that's the goal for this particular presentation here today. All right, so my starting point is, as I said, what is augmented reality? If you've never heard of augmented reality before, and I'm pretty sure that there are still lots of people out there in the wild that don't know about augmented reality. So essentially, augmented reality, or AR, means that you are combining the reality around you, the environment that you live in, with additional computer-generated data that is linked to this reality, into this environment. So it kind of gives you some additional information on your surroundings. So these are essentially the 2 main components: the view of the real world. Here we are obviously in Times Square in New York, and we're looking at this, at the houses and this famous pile here. And we are obviously augmenting this Times Square with some additional information, like, at this particular location, there's a Starbucks or a coffee to go, and what have you. So that's the basic concept of augmented reality, combining the reality with virtual data. And now there are several use cases for augmented reality, or let's say 2 main categories, how we can utilize the concept of augmented reality. Number 1 is location-based augmented reality. That's essentially similar to the example that you've seen before with Times Square. Essentially, you are walking, in an environment, and based on the spatial sensors that are in the device, the GPS or other location-based sensors, plus some, accelerometers or compass or gyroscopes and what have you, that sensors that are built into the device can calculate what is actually currently in your field of vision. And then in the background, usually in huge databases, there are lots of points of interest that are stored with latitude and longitude, and essentially then the phone can actually calculate where these points of interest are actually going right now in your camera screen and can project additional information. So taking the example of London here and the Big Ben, so you are right in front of Houses of Parliament and Westminster Abbey and Big Ben and all the things that you have here in London, and you point your phone towards these buildings and you get some additional information. Obviously, that's kind of the use case where augmented reality was born with, and also where Wikitude was born with. The idea that you have lots of points of interest or a huge POI database, and you display it in an augmented reality view. So that's the first use case category for augmented reality. The second use case category is vision-based augmented reality. That essentially means that you're not taking the sensors in the device as your main source of information, what you're actually looking at right now. You are actually analyzing the camera view, or the camera frames that you actually get from the device. So here, for example, you are scanning some kind of box from a a motorcycle manufacturer, and you want to kind of augment this box with some let's say marketing material or whatever you want to augment it with. Essentially, the device is understanding that it looks at this particular box, the device is recognizing it, and is then projecting this 3-dimensional model of the motorcycle on top of this box. So that's, again, vision-based augmented reality. So taking the camera input as the main input source, and then trying to understand what is actually currently in your field of vision. So these are the 2 different kinds, and essentially, that's right now what augmented reality, or all the use cases that augmented reality comprises right now can be grouped into one of these two categories. So these are kind of the state-of-the-art augmented reality use cases. All right. So why is Wikitude interested in that? What is Wikitude? And essentially, what is this company doing? And how do we relate to augmented reality? Obviously. So Wikitude, the company that I am with, is an augmented reality software technology provider. That means that we are building tools for augmented reality, or for augmented reality developers actually, to create their own augmented reality experiences with our tools. So you can envision that, especially this vision-based augmented reality, but also, of course, the geospatial augmented reality use case, are very, lots of algorithms are in the background. It's computationally expensive, lots of things that you have to consider. And, if there were no tools and libraries that you could use, then you would have to start developing from scratch and reinvent the wheel each and every time you develop an augmented reality application. And with the tools that we have, you can actually ease your lives by using the tools and developing it. So, I mean, you see a couple of numbers here. We are actually operating worldwide. We are headquartered in Salzburg, in Austria. But we have customers all over the world, lots of different AR developers and AR applications that are actually built with our tools. And then second and last kind of marketing slide, let's say, is what products we have. Essentially, our main product is the Wikitude SDK. So as I said, the technology provider, so the technology library that you can download and use for your own Android and iOS applications to create augmented reality content. And then we have a couple of other tools that are helping the SDK or helping you as developers to utilize the SDK, like the Wikitude Studio, which is a content management system for AR, or cloud recognition, which essentially allows you to do vision-based augmented reality on cloud-based servers. And a couple of others, essentially also the publishing app or the Wikitude application that the company grew famous for. Essentially, we have an app in the app stores that you can download and try augmented reality and publish your own experiences that you have created with the SDK, to people essentially. So much for augmented reality as kind of an introduction and Wikitude as such. Now let's dig a little bit deeper into the main topic of this presentation, which is ARML 2.0. And so essentially in the beginning, the first question is, why is there at all an ARML standard? Why is there the need for augmented reality, a markup language, and something like that? So essentially, I want to take you back to 2009, when augmented reality grew some significant, let's say, traction from the developer community. It was really hyped. Everyone was interested in augmented reality. And so, the first applications came out. We developed our own Wikitude app, the Wikitude Vault browser, as it was called. And we had a couple of other big players in the field. For example, Layer is a Dutch company, and Genaio is a German company. And a couple of others that also grew strong in the augmented reality segment. These applications that were built are all called augmented reality browsers. An augmented reality browser essentially has the use case that you can, very similar to a web browser essentially, you can upload content and then the web or the augmented reality browser will render this content for you. So as a developer, you would go on to Wikitude.com. You would find a menu where you can upload your own content in a particular format, in an XML format that we used back then, and then you upload it to Wikitude, and all the users of Wikitude will actually see the content that you have uploaded in their browser if they want to see it, if they select it. So this Wikitude application had its own content interface, the Wikitude XML. On the other hand, of course, there was Junaio, which was a competitor. So also Junaio had the same idea of an augmented reality browser and was developing their own content interface, also an XML interface, but of course incompatible with the Wikitude XML. The same for Layer. They decided to use a JSON, which is called Layer JSON. And, well, obviously then lots of other people developed their own augmented reality formats. And so for this poor developer down there at the bottom of the slide, of course, this was hell. Because if you want to do decent augmented reality development, you want to reach as many people as possible with your content, obviously. And assuming that there are, let's say, 10 different augmented reality browsers and none of them has a standardized content interface, that means that you have to create your content in 10 different languages, which are all slightly different but do similar things. And this is just a nightmare for developers. That's something that we do not want to do. And that's why essentially we started having ideas around creating a common augmented reality interface format that all the applications can make use of. And this is essentially how the idea of ARML was born. In a quick summary, what augmented reality markup language 2.0 actually does, what's the scope of the standard. As you've already seen, and if you've used augmented reality applications yourself, you see that augmented reality is a diverse field and you can do so many different things. So we had to limit our scope and kind of define it and say, this is what ARML 2.0 stands for. And this is what we came up with. Essentially, ARML 2.0 is a data format that allows you to describe your own augmented reality scenes. So kind of, describing what virtual objects are there, if you're in a geospatial environment, what are the latitude and longitude coordinates of this particular object, things like that. So it's a descriptive format that allows you to describe these things. And then we also offer a JavaScript binding interface that allows you to manipulate the scene, once it is running. It's very similar to HTML and JavaScript playing together quite nicely, where with HTML you define your own, the web page essentially, and with JavaScript you can then interact with it, react on user input and things like that. And so these ideas were essentially taken from HTML and JavaScript development and put into ARML 2.0. So it's, again, a very, very similar and essentially the same concept that you would find in web browsers. All right, what is the standard, the main building blocks of the standard? What are those? And this is maybe the most important slide when we talk about ARML 2.0 in this presentation, because it summarizes, when you want to write your own ARML 2.0 file, what are the building blocks that you have to consider specifically? So let's start from the left side and move down to the right side. So when you read that sentence that is actually down there, it says a feature as an abstraction of real-world phenomenon has anchors in the real world, which have assets representing the feature in the virtual world. That's a bit of a complex sentence, but I will walk you through what that means. Essentially, a feature is the real-world object that you are considering right now. So let's take the example of the Eiffel Tower in a way. This would be the real-world object that you want to deal with. So either you want to augment it with something or you want to recognize it, whatever. But the Eiffel Tower, the real-world object, would be the feature. It's kind of, as it says there, an abstraction of a real-world phenomenon. And the real-world phenomenon here is the Eiffel Tower. That definition, by the way, was borrowed from GML, the geography markup language. If you've ever used that, they also talk about features being an abstraction of a real-world phenomenon. All right, so now we have the feature, kind of, the real-world object. And obviously, the next step is that we have to locate it in the real world. So we need to tell the application where this feature is actually located. This could either be a geospatial location, like here. I mean, the Eiffel Tower obviously is not in the South Pacific Ocean here, but never mind. It's a latitude and longitude coordinate essentially. That would be the anchor. So it's kind of a broader concept of a location, because It does not necessarily have to be a geospatial location, as you've seen in the introductory slides. Augmented reality can also deal with the vision-based part, where you take the camera as your input. So essentially, an anchor could also be some visual object that you are recognizing in the camera screen. Could be a marker, as on top of here, on top of the slide, you see a marker that could be recognized, but it could be anything. Could be, this box essentially that you've seen in the motorcycle example. Just some kind of visual pattern, visual thing that the application can recognize. That's an anchor. And that's why we did not choose a feature has a location, because location would be too narrow, because it would just consider geospatial locations. That's why we say it has anchors, because it includes geospatial locations and visual patterns that can be found. Okay, so now we have located that feature in the real world, and now we need to let the application know what should be augmented as soon as the this particular anchor has been found. And that's what the assets or visual assets are actually there for. So these things are representing the feature in the virtual world. This could either be an image that is projected onto the camera screen as soon as the pattern has been recognized, or a 3D model, or a text, things like that. So there are several different ways how assets or how features can be represented in ARML 2.0. We have several kinds of assets included in the standard, and so that we can support a broad range of use cases. So essentially, an asset could theoretically also be HTML content. So you can define whatever HTML content you want, and it will show up in the camera screen of your device when you are using the augmented reality application. All right, so where do we stand with ARML 2.0? As was mentioned already in the introduction, for ARML 2.0, like a month or 2 months ago, it was a very important date, because ARML 2.0 was essentially published as an OGC accepted and adopted standard. So the way ARML was developing was that when we go back to this slide that I've shown you at this particular situation where we had so many different formats, Wikitude kind of proposed to the AR community that we should get together and create a standard, which was then ARML 2.0, and we proposed it to the OGC, the Open Geospatial Consortium, which I guess you are familiar with, the standards organization which deals mainly with developing geospatial standards and GIS standards. And so the OGC, liked the idea. We founded a group, and we, developed the ARML 2.0 standard within a group of 50 institutions actually, and I was chairing this group. So now coming back here, what's the status of ARML 2.0? It is an adopted OGC standard and is already being used. And that's the very good news for a standard always, because a standard is only as powerful as the number of people that are actually using it. Good news about ARML 2.0, over 50 million users are already using ARML 2.0. And that's because we used ARML 2.0 to essentially, bridge the gap between these formats that we had for Leia, for Wikitude, and for Junaio. So these browsers in total have 50 million users currently. That's what we got from our company numbers. And we teamed up these three companies and said, let's find the how can we map the formats that we have to ARML 2.0 so we can use ARML 2.0 as an exchange format between these browsers. And so essentially that's this diagram shows already what we did. We took these different formats, we wrote converters for ARML 2.0. So a developer that would want to create augmented reality content in a particular browser language can still do so. So a Wikitude developer, for example, would still go to his Wikitude content interface, would create his own content in the Wikitude XML format, but internally then it is converted into ARML 2.0. And essentially, if a Layer browser user now wants to consume that content that was created in the Wikitude format, then the Layer backend will contact the Wikitude backend and will ask for this content in ARML 2.0. The Wikitude backend will send it back to the layer browser, and the layer browser will then parse ARML 2.0 files and will present the content to the user. So here is really as an ARML 2.0 as a common interchange format between the different native browser languages. So here we applied ARML 2.0 to a scenario where we already had content available, and we had to convert it to an interchangeable format, which was then ARML 2.0. These browser implementations are not something that was just an experiment or something like that. These are actually live. So whenever you download your Wikitude layer or Junaio application, you already have an ARML 2.0 powered application in your hand, and you can try and fetch Wikitude content from the layer browser or from Junaio, and whatever you want, it will work. So that's really awesome to see that, and was a huge success that we did that. There is another example, actually SK Telecom, which is kind of the main mobile network provider in Korea, in South Korea actually. SK Telecom is based in Seoul. They implemented their own augmented reality browser, and they when they created the browser, they were looking for content content formats, and they actually found ARML 2.0 and built their content interface specifically for ARML 2.0. So here it's kind of the other way around. Here ARML 2.0 was there first, and then when they created their own augmented reality browser, they used the format as the main input source. So we kind of saw that both ways work, right? ARML 2.0 can be applied to scenarios where we already have an application, and it's sufficiently strong that people can actually build their own applications around ARML 2.0 in a way. So these are the implementations, and as I said, right now it's estimated that 50 million users are using the format, which is really cool. I'd like to walk you through an example of ARML 2.0. So we're going a bit concrete as well. If you fancy some XML, that's just hang around and stick around, because essentially this is just a very, very basic and teeny tiny example of how you could make use of ARML 2.0 and what you essentially have to do. Here I take the example, a geospatial example of the Golden Gate Bridge in San Francisco. So you're obviously at a particular or close to the Golden Gate Bridge, and you want to augment it with this particular icon, which is a kind of the Wikipedia ball. I just took this example because it's already there in a way. So what would you have to do to create this in ARML 2.0? So essentially that's the code on the left side, and I will walk you through now one step after another. Each augmented reality, each ARML 2.0 file starts with this tag ARML. I guess you're familiar with this. This is kind of standard XML like you would see in HTML or KML and things like that. Then all the particular objects, like the features, the anchors, the assets, as I've shown you in the previous slide, they're actually put into the AR elements tag here. So this is kind of the rough sketch of the basic outline of ARML 2.0. Let's start with the feature. What would you do to create this scenario here? Obviously, the feature that you are interested in is the Golden Gate Bridge. So you say the feature with an ID Golden Gate Bridge has a name, has a description, has some, I didn't include that here, but you could add any metadata that you want, like, I don't know, the length of the bridge or when it was built and whatever. So you can use your own schema here. You can place in any metadata as you want. So now we have the feature defined. Next step is defining the anchor, which in this scenario means defining the location. Here I took a simple example that the Golden Gate Bridge is represented by a particular point with latitude and longitude coordinates. It could also be a line string, could also be a polygon, as you want it. So we support different ways of locating a particular feature. But here, just to keep it simple, this feature has this particular anchor, which is a point on a particular location. And then the last step is the visual asset that you want to see on the screen. So here I'm using this image, has an ID, has a particular width. The width is in meters of real-world objects. So that means wherever you are, this particular, the particular image will appear 20 meters wide, as if a normal object in that particular distance of 20 meters would appear. So, this is about 20 meters, as you see here at this particular location on the bridge. And then you have the link to the image that you want to present here. That obviously is a fake URL, but you can place in any URL as you want it. And so now the last step is obviously, now we have the feature, we have the anchors. Now we need to map the image into the anchor here, and that's done using the assets ref. So here you are referencing a particular image that you have defined in the file to represent a particular point. You do not necessarily have to do this. You don't have to use the asset ref. You could also place the image directly into the anchor here. But just, there could be situations where you want to reuse the same image over and over again for several different POIs. You want to always augment each and every POI with this Wikipedia ball instead of having it to define like, I don't know, 100 times in the same file. You just define it once and then reference it. The same, by the way, goes for anchors. So you can define one anchor and then reference it in several features if you want. All right. So that's the simple example of ARML 2.0 in use, which essentially also concludes my presentation here. And before we go into kind of the post phase, and I will answer some questions. If you want to reach out to me, this is my email address, martin.lechner@wikitude.com. And this is also the URL where you can find more information about ARML and the standard specification itself. It's under the opengeospatial.org domain, and then /standards/ARML. You will find some material and the specification, obviously, and also the XSD and some examples will all be included in that package. All right, so that's it so far from my side, and well, if there are any questions, then I'm happy to answer that, and I will hand over again to Gudrun Valentin.
Thank you very much for a very inspiring and interesting talk that I think triggered many questions. So I will start with one from a student who asks, what knowledge or background do you need if you want, as a student, if you want to study and work with augmented reality and use the ARML standard for your projects?
Oh, that's a very interesting question, because there is no definite answer to that. Essentially, it depends a lot on what you want to do. If you just want to play around with AR and just create some content, I mean, all you need to know is some XML, and I guess that that you can. Hello, by the way, that's me. That should be very easy. You need some XML knowledge. You need to know how to format an XML accordingly, and that's it. You don't have to do anything else. If you want to develop your own augmented reality application, that's obviously when things get a bit more interesting. So there are several ways to do that. I could advertise now that you use the Wikitude SDK for that, but that's, of course, you can choose. But essentially, then you would need some Android/iOS knowledge to create your own application or your own browser or whatever you want. And well, there is, of course, then the big step when you want to create everything from scratch. Then you would definitely have to have a decent knowledge in either image processing or at least some GIS systems. But that depends on your use case, whatever you want to create. That, well, of course, depends on your skills and on your use case.
Right. So from very easy to handle applications to very advanced application development, I guess.
Right.
I have another question from obviously a user of an AR application. He says that he is using a mobile phone and with here maps and using a function named Live Site, which is an AR app. And he said the quality of this Live Site is poor and frustrating, and he wonders if the new standard that you presented is being implemented, and whether and how this standard can improve applications like this.
Okay, well, the standard itself will not be able to improve the applications because the standard is a data format. So it's mainly for developers to create their own content. It's still up for the application developers to parse that content and create some, high-quality applications. The standard does not create applications. The standard is there for applications to be used. So I don't know if Here Maps is going to implement ARML 2.0. That's beyond my knowledge so far. But as I said, it's still up to the application developers to really create very precise, very accurate, and very well-performing augmented reality applications.
Okay, thank you. With another question here. So one student is asking, when the anchor is defined as a point, is there a buffer around it that will trigger the pop-up?
No, because I would assume that when you the question is, why would you need a buffer? Because, envision that you are at a particular location, you will place the marker on top of your object that you want to augment. When you move your camera phone, as soon as this marker is somehow visible, then you will see parts of it. At least I assume that it's going to be implemented that way. So you wouldn't really need a buffer, because then, what would you do when parts of the point are actually visible? Would you float the marker around? And I wouldn't say that this makes sense, but it depends on the use case. So if there is a particular use case that makes sense, and then we can consider it, because obviously ARML 2.0 now is the first step, and there are always ways to improve.
Okay, thank you. So that leads me quite nicely to another question related to the visualization. So are there any best practices for visualization of those markers? Personally came upon one or the other study, but there were no clear guidance what kind of visualization should be used that's intuitive for the user.
Yeah. So I can speak for two main categories. One is when you want to augment with a 3D model, and the other one is when you want to augment with some more information like text or images and stuff like that. For the 3D model, it's inherently important that the model is not like 200 megabytes in size, because usually augmented reality applications are running on a mobile phone. And that means that the mobile phone has to download it, has to process it, has to render it. And even though these guys, the mobile phones, are really, really powerful by now, they're not desktop PCs. So that's different. So that's kind of the best practice that I can give to you. Keep the models simple, because they will be on a small screen. So I mean, there's no point in going totally detailed. The second part for images and text and stuff like that is keep it simple, because users will not want to look at a screen where you have bubbles and markers all over the place, and he's not able to select a marker anymore. So this will be very important. It has to be small, still clickable, of course, in a way, but simple. And then, of course, also in ARML, you can specify that when you click on a particular marker, then something appears like like a new web page or just some text at the bottom of the screen, which gives some more information, so the user can actually take down the phone and read it. So then you can get a bit more complex. But for Marcus itself, it should be very, very simple.
Okay, thank you.
Right, thank you. I have a question from the other side. So we were talking now about the 3D, what you call assets. What about the anchors? Are these routed from GML imports, or which standards do you use there?
For the geospatial location, for the geometry, as you've seen it, yes, this is imported from GML, so we don't redefine that. We just make use of what they defined already, and they did a good job in that. And obviously, if it's not a geospatial location, if it's more like, well, this visual pattern, there was no standard yet, so we had to define something, from scratch. And, well, that's essentially what we did.
Right. I was wondering why this question didn't pop up earlier. So there is one question, very simple question. Does Wikitude offer any student edition for their SDK?
We do offer an educational license, yes. That's actually free of charge. But the Wikitude SDK is free to try anyway, so you can download it, and as long as you do not publish an application, we don't charge you. So that's fine, especially when we talk about courses and Wikitude SDK being used in university courses, which is always, of course, very interesting and inspiring because we get lots of feedback. We also do offer some educational license, so if there's any need in a course, then it's no problem. Just shoot us an email, and we can chat, and we can issue the license. If there's something published, then there is a license. That's just that simple.
So I think that's a very nice offer to all the students. Go out and test and develop and play around with Wikitude and get some experience with augmented reality.
Okay, so we have another question. What 3D formats should be used, and are there best practice examples for tree count or texture size?
Okay. Good question here, and this was something that we very, very particularly chose for ARML 2.0. It's again up to the application what 3D formats they support, because we know that everyone has his own beloved format, maybe FBX or Collada or all the other 1,572 formats that are out there. So we suggest that each and every application supports Collada because it's an open standard, there are no restrictions, and ARML is an open standard, so kind of helping the open standards idea. But if an application wants to support FBX and you supply FBX, then fine. That's also something that you can do. So we kind of try to define a format, Collada, in this way that each and every application supports, so we have a common ground to start from. And if you are so particularly keen on having an FBX model and the application supports it, then you can also supply that.
Mm-hmm. Okay, thank you.
There's another question regarding application. So there is a student who is involved in construction, and he wonders if you have any experience with construction augmented reality apps, so visualizing pipelines, etc. And he says, I would like to know the accuracy of these types of apps and the growth in its usage. I mean, I know that one or two customers of the Wikitude SDK are building something like that. But in this case, I would ask you to please shoot me an email, because I don't know from top of my head what exactly they are doing and what accuracy they have. But if you shoot me an email, then I will be happy to to find that out and provide you with some more information. I don't have the answer right now.
Okay. Another student is asking whether you can estimate the area that is covered by augmented reality features so far, and what is the percentage of places covered there? So maybe this is related to Wikipedia as well.
So what I know, I can speak for Wikitude. You know, we have lots of different content sources in the application. We have Wikipedia, we have Google, we have Yelp. I don't know. I think right now the number is like 5,000 different content sources, including, of course, the content sources that people have uploaded. The total coverage, I don't know. I mean, I just know that some analysis has shown that we have like several tens of million POIs in the system. Doesn't necessarily have to be in our database, of course, because we don't copy the Google database. But you know, we have access to these content sources. The exact number, I don't know.
Right. Another question that leads us towards the areas of applications where you can use AR. So there is a student asking, do you have any project running with emergency management? And if yes, if you can give examples for that.
I know that, so Wikitude, no, we don't have that because, as I said, we are not application developers as such. What I do know is that there is the Technical University of Vienna, which is quite strong actually in the augmented reality field, and they have a separate division dealing with that. They are experimenting with things like that. So they want to find ways when you are in a building and there's a fire and you don't see anything, but you know that there is a person to rescue in there, to kind of use augmented reality to aid the fire workers to get to that person in one way or another. I've seen several videos on YouTube that shows kind of this use case. So that's the knowledge that I have about this. As I said, we are not application developers, we are providing the tools. So there could be a lot more applications in this domain.
Mm-hmm. So there's one more question related to maybe that what you're more involved with. So is there some plugin into GIS so that GIS students can make use of it?
Sorry, could you repeat the question, please?
Well, the question is phrased whether Wikitude has made some apps for GIS, but maybe the question is related to a coupling, somehow coupling GIS with augmented reality, whether there is a plugin for a GIS software or something like this.
I mean, yes, of course, Wikitude has created GIS software because, we created the Wikitude world browser. So essentially, we were connecting to lots of different content sources in the background and using the GIS data that we had to visualize it. Well, essentially what you would have to do when you want to create this is, use the Wikitude SDK. We have a high-level library that allows you to supply essentially latitude, longitude, and say, this is how I want to augment it. So very similar to also what you saw in ARML 2. That's essentially what you have to do. So you need a database with POIs, and you need the visual assets, and that's it. You write a couple of lines of code, and off you go.
Okay, thank you. So we have a final question from another person, and the question is: GML is large, why not using JSON?
Yeah, good point. So essentially, how ARML 2 is built is we have defined a very generic object model without any particular language that kind of serializes it. So the object model, you could implement that in Java, you could implement it in JSON, in whatever. So either programming language or markup language or whatever. The reason why we chose XML for the main serialization is essentially political reasons, because we know that the Open Geospatial Consortium is doing a lot with XML, is now moving a little bit towards JSON as well, so that's good to hear. And for the ECMAScript binding, or for JavaScript binding, as I was mentioning in the presentation, we obviously also have a JSON representation of the object model. However, as I said, fitting in with GML, with Open Geospatial Consortium best practices, we decided that in the very first version we start with XML. But obviously, as we know that the Open Geospatial Consortium is also moving towards JSON, we will also have a mapping for that very soon.
So you have reached a big milestone. What would be next?
Yeah, that's a good question. What I'd like to see is a lot more implementation still. I mean, we have now these 4 implementations that are live. I know that there are several implementations that are currently in the works. So it will, they will, see the light of life over the next couple of weeks and months. I definitely want to see more. I have already, together with my group, compiled a very, very long list of additional features that were also requested. And so, kind of that will be the next step, implementing or seeing what the community really needs, see what the community thinks about ARML2, and then, well, fixing the bugs, adding new features, kind of as you would expect from a, from a computer science project. I would say that's how we will go about it.
So the shoes are there and now we need to start running.
Right, exactly. The tools are all there.
Right. Thank you very much for this very interesting talk, for this interesting discussion. Thank you a lot, and thanks for the questions to all the students. We are looking forward to yet another U lecture in this semester, which will take place in around 2 weeks' time. And for this lecture, we have another interesting speaker invited, Dr. David O'Sullivan, who will talk about agent-based modeling, about spatial patterns, and simulation. It will be on the so I need to sneak. I think it's the 12th of May. Registration is already open, so just go to our website or the blog and sign up for the next U lecture. This U lecture was recorded, so recording will be available in case you want to see it again or tell friends about it. Feel free. We will distribute the link to the YouTube recording in a couple of days, so we can look forward to that. And see you again in 2 weeks. And thanks again to our speaker and to all of you. And I wish you a good evening from Salzburg.
Okay, thank you very much. Bye.
Thanks a lot, everyone. Bye.